Okay, so let's take a look at this question. We've got a circle, not in any form of standard form, and then we've got a point, and the question is, what's the distance from A to the point of contact of the tangent of the circle? So it's quite a cool question because, in fact, I think we're aware that there are actually two tangents. There's one that sort of goes down to the right and one that goes down to the left. But we also know from our circle geometry that, in fact, those tangents have the same length. Okay, I'm going to draw in one of those tangents. All right, there it is there, not very well drawn, but anyway. Now, if I could find the center of the circle, all right, then I could work out, and I would obviously, if I found the center of the circle, I would also know the radius. I'd know the length of this green line, right? But if I know the center of the circle, then I could work out the distance from the center to that point 8, 12. All right, and that would in fact be the length of this blue line. Sorry, which is not going where it's meant to go. Let's just try that again. Okay, so not very well drawn. All right, but remember that a radius is perpendicular to a tangent. So I can use Pythagoras. If I know the green line and the blue line, then I can use Pythagoras. I'm going to call the blue line L, and I'm going to call the red line T for tangent. Okay. So let's just quickly put this circle into standard form. It's actually x squared minus 6x plus y squared plus 4y equals 0. Right, remember I want to write it as something squared plus something squared equals something. Right, remember that when I square out this binomial, whatever I put here is going to double, so I need to halve it. So if I multiply this out now, I get x squared, that's great. I get minus 3x minus 3x minus 6x. I also get a plus 9, which wasn't there. My scale, I like to use the metaphor of a scale for equations. My scales are kind of imbalanced, so I'm going to add 9 to the right-hand side to restore that balance. Exactly the same with the y's. Y plus 2. When I square this out, I get y squared, I get 4y, and I also get 2 squared, which is 4, which I didn't have on the left. I've added it to the left by writing it in this form, so I must add it to the right. Okay, sorry, I've gotten ahead of myself, 9 plus 4. Right, 9 plus 4 is actually equal to 13. Now, that is actually the radius squared. So the radius is actually the square root of 13. Right, but as we're going to see, the square of it's actually more useful. L squared is the length from the center, which is now we know is 3, negative 2. Right, so I'm going to work out the length from 3, negative 2 to 8, 12. But I'm not going to bother to square root it. So in fact, L squared is actually going to be, it's 8 minus 3 all squared. It's 5 squared. And 12 minus 2, 14 squared. Right, so L squared is actually 196 plus 25, it's 221. That's L squared. All right, I know from Pythagoras that T squared is going to be L squared minus R squared. So in fact, T squared is actually going to be 221 minus 13, that's my radius squared, all right? And that's 208. So the tangent length is actually the square root of 208. Okay, I'm going to leave it in that form. We could put it in a decimal form as well. Hope that helps.